Okay, this is section 18.1. It's a very short section on introducing the idea of spontaneous processes. Okay, so some chemical processes and some physical processes are what we would call spontaneous, which in one sense means that they will occur on their own under a certain set of conditions. Another way of thinking about it is that a spontaneous process is one that occurs without a requirement that energy be put in to make it happen. Okay, so spontaneous. They're also what we call the opposite of that, a non-spontaneous process, which is one that does not occur under a set of circumstances. So let me show you a couple of common processes. One is combustion. So if we take methane and combine it with oxygen to produce carbon dioxide and water, it turns out that this process is spontaneous. It does occur at room temperature, and it's also highly exothermic. Right? If you remember, delta H, the enthalpy change for a process, is a measure of heat transfer under constant pressure. So if the heat transferred is out of the system, in this case the reaction, and into the surroundings, and if the energy goes out to the surroundings, the heat goes transferred to the surroundings, we would call that an exothermic process. So it turns out this process is highly exothermic. And it's also spontaneous. So we might make the argument that spontaneity, whether something occurs under a set of circumstances or a set of conditions, is related to the enthalpy change. And in fact, it is. So here's another example. If we take H+, the hydrogen ion, and combine it with the hydroxide ion to form water, this process is also spontaneous. So if you take a strong acid like HCl and combine it with a strong base like sodium hydroxide to form water, it's a vigorous reaction. And it turns out it's also pretty exothermic, not as much as a combustion reaction, at least the combustion of methane, but it is exothermic. So this one is also exothermic, but it's also spontaneous. So there seems to be a relationship between the enthalpy change for a process and its spontaneity. Okay? Now, here's an example. Suppose we take an ice cube at room temperature. So that could represent an ice cube, right? Solid water. We know that at room temperature, the spontaneous process is that ice will melt into liquid water, right? But it turns out this is not spontaneous. I mean, it's not exothermic. It's actually endothermic, right? That's an endothermic process. Let's put 25 degrees C here, room temperature. But it is spontaneous. Furthermore, suppose we do this. Suppose we take liquid water and try to freeze it. Now, if the temperature is at 25 degrees C, what would delta H be? So if you think about it, this is the reverse of the equation I just wrote up above. So it's exothermic, right? So this is exothermic, right? The freezing of water. But we know from our experience that the freezing of water is not spontaneous. So we call it non-spontaneous. at 25 degrees C. No way. It does. Water doesn't freeze into ice cubes at room temperature. However, suppose I change the temperature and I make it instead minus 25 degrees C. Now it turns out the enthalpy change for these processes don't change very much. So it's still an exothermic process, right? But now it becomes spontaneous. So the key here, the point we're trying to make in this very brief section, is that it appears as though predicting whether a process is spontaneous or not is in some way related to the enthalpy change. For processes which are highly exothermic, they tend to be spontaneous. But if the process is only somewhat exothermic or endothermic, it seems to depend on temperature. So for example, at 25 degrees C, the freezing of water, although it is exothermic, is non-spontaneous. Change the temperature to negative 25 degrees C, and suddenly this process becomes spontaneous. So what we'll see as we continue on in this chapter is that there is a second factor related to the spontaneity of a process. And that second factor is called entropy.